are my two teammates, Jessica and Angela. So I'm going to start by introducing what Pygame does. It's just like a package that helps you, like, it has many useful moves for games. Like for the ping pong game, it's a paddle and there's display player 2 and player 1, like those. Pygame.in, it just initializes the Pygame. It's the opposite of what Pygame.quit does for this. Set the screen width and screen height sets the screen dimensions. And set title just makes the captions on below the output mark to make it look better. We chose the colors black and white because we just went for the simplicity, or the colors would be kind of eye-shocking. And then the paddle dimensions, we had to make the same, but they couldn't occupy too much space, or else, like, you didn't have to move your paddle and then you could hit all the balls. And of course, they had to be the same size just to make it fairer, and not just because of the automatic goal blocking thing. And sometimes we have like a little glitch where the ball just goes back and forth, and it doesn't really do much. And then one of the players has to lower their paddle to let the ball go through, and so the random will let you respawn the ball in a different place. And the player 1's paddle, same size, same speed. Player 2's paddle, same size, same speed. The ball also has to be the same size because there's only one ball. And it has to be the same speed so that it doesn't just like go really fast and then makes it really hard to win. And the score, it makes sure that when you press the run button at the top, every player's score starts as a 0. The game loop, it just makes the game run like over and over again instead of just using an infinite 4i in range command. For the event in Pygame.get, it's just handling the event. For the Pygame keys, it just allows you to control the paddle by pressing either WASD for one paddle or the up and down arrows for the other paddle. And of course, the ball movement, it has to be the same for both the player 1 and player 2. Or like when the player 1 hits it, it goes really fast and player 2 can't get the ball. That would just be plain biased. The ball's collision with walls, it means that if the ball hits the wall, the other person gets a point, as demonstrated here. And then when the ball collides with the paddles, the ball will reflect, and then it won't just like pass through the paddles. For the scoring, it just makes sure like every time it touches the wall, the other person gets a point. And then if we scroll down, you will find the draw objects. It just like draws the paddles and the ball itself. To display the score, it just writes the number and continues adding 1 to it, so you can keep track of the score. And the update display just makes sure it's seen. The limit frame rate thing just like makes sure that the time and the clock, the tick is like is set to 60, so it's not too fast and not too slow. And Pygame.quit does the same for the Pygame as it does for Turtle. It just stops the game, and without it, then the entire thing wouldn't run. Thank you, and goodbye.
Okay, so me, Jeremy, Jara, Samuel, and me, Aiden, our team Isaac. We made Tetris. Okay, here's a demo of what we have done. Okay, some challenges. Some challenges we have faced are how to represent the board of Tetris and the blocks, how to store the blocks that have fallen onto the board, and how to detect collisions, how to detect and erase a full row, and how to rotate a block. To begin with, we represented the board and the block with two 2D arrays. The board, which is 20 by 10, and the falling block array, which changes lengths and widths depending on the shape. For the L shape, it is 3 by 2. To store blocks that fall onto the board, we have to copy the block that's landed onto the board to where it lands onto the board from falling block to the board array. For example, the L shape has fallen to 0, 8, 0, 9, and the rest of the blocks. So we have to transfer that from falling block to the board. We detect the collisions by keeping track of the falling block on the board. Before the block moves to a new position, if the cells of the board are already occupied, we would stop the block from moving. For example, the square is about to fall onto the 0, 5. Because 0, 5 has already occupied it, we stop. For my collide function, I made it so if the block rows and columns that are not filled and the ones on the falling block aren't filled, then that means we are collided. That means the block on the falling block has touched a filled block on the board array. And we repeat this process, and if we get any of the truth, we know we have detected a collision. If not, we return false. To detect a full row, we check if every block in a row is filled. We raise a full row, number 2. Okay, first we clear every cell in the row. Second, we copy over the filled block from row number 3 above to the row below. Here we check one by one if the row is filled. And if all of them are filled, we raise the whole row, as shown here, to an empty. Here's how we detected and we raised the full row. First, we cleared row 2. After that, we lowered the blue block to one row below, to row 2. Finally, we lowered the orange block to row 3. To rotate a block, we created a this is a 3 by 2 block in L. To rotate that block, we create a new 2 by 3 array, and we copy the block from falling block to rotated block. That's the new array by copying first n row to n column, and the first cell in the row to the last cell in the column. Okay, we put it together by first our main loop runs forever until the game ends. First it draws the grid and board, then it checks for collisions, and then it checks for landing. If it is, we copy onto a board, we check if the row is full, and if so, we erase it. After that, we generate a new block. Finally, we make the block fall if it's not collided. Then we draw the falling block all over, and then we print the score. We also have some key press mirrors called move left, which moves the block left, move right, drop down, which drops it very fast, and of course rotates. Thank you.
I used Pygame, so we go import Pygame, import random, import SYS to make it work. Here we do how big the screen is, so screen width 300, screen height 600. Then we do block size equaling how large each block could be. Here we go. And then these are the colors of each block: black, white, cyan, yellow, purple, green, red, orange, and blue. These shapes are the size of them using 1 by 1 by 1, or 1, 1, in parentheses, 1, 1. Then we do shapes equals colors: cyan, yellow, purple, green, red, orange, and blue. Then you do screen equals Pygame display set mode, screen width, screen height, which is from like up here. And we do clock equals pygame to time.clock. Here's how we get like the collision. X offset, Y offset equals offset. So this is basically saying if there's already block in that one space in the grid, that means it cannot go there and it'll just stack on top of it. And if it goes together, if you get one line across, it'll just delete that line and it'll move the line up from above down to where that line was. Draw the board. Here's how we like get the grid, and here's how we get the pieces. So it'll pick a random piece and it'll draw it. This is like all the events and stuff. So it's just like if a block is there, then it'll slowly go down. And here's how we get it. So if we do like K to left, K to right, K to down, that's just rotations. And this is just down, so speed it down. And every time you get ticked, then it'll drop faster. And that's kind of it.
This is a platformer. Let's dive right into the code.
So, for project, I present a platformer. By the way, sorry if the audio is a little glitchy. If it is too glitchy, then I'll just record it later. But I don't have the best mic. So, as you can see by the overly dramatic intro into the game, as just as the name suggests, a platformer, there's this little fella traveling through a land of monsters. The mechanics are simple: the movement system, the monster, the damage system, and the life system. Those two are basically the same thing. I made this so it can be easily edited and new levels can be made without typing a million lines of code. So let's dive into the code. Now, I will be explaining over each line of code, but I will sometimes refer to an entire paragraph for the purpose of reducing redundant text. I also skim over similar identical parts to make sure this video isn't going to end up being 10 hours long. Just see it as an overview, 1. You have the most important parts, the initial setup. These are the import libraries as you can see here, and there's tons of different libraries you can download. Most of them you have to download. The import JSON is for reading level data, Pygame for game development, and Sys for systematic functions. And for the pygame.mixer.pre_init initializes a sound mixer, while pygame.init, the shortened version, initializes all Pygame modules. These are the game configurations, and most of these come in later for the font setups and other things. Most of these just get toggled on and off later on. But these are the main settings. We like to usually put it to the front later for some reason. And of course, there is options and controls over here. These are just to define constants for the window titles, dimensions, frame per second, aka FPS, and the size of each grid cells using stream. Also includes sound off each stream. In case you're wondering, this is just a random boolean to control the sound. Like for example, if I run it now, if I run it now, my ears will get blasted by overly loud music. While if I have it off, if I have it off, it'll just not do it. Obviously. For some reason, but it's a required boolean. It's annoying, but necessary for some reason. There's colors, and there's a colors, which is really just a bunch of serial numbers, which is fine because I don't want to be stuck to the preset level plates, and the levels for the world.jsons, which is in these files right here. I'll get to use these later. These are mostly for configuring the levels. And then there is the fonts and images. These are just pretty simple and self-explanatory to upload all of the assets. So if you go over down here, these are the ones that replace the blocking nicknames as block images to define them as these two-digit uppercase letters as these images. And then we use those so we can use these in these categories, and as a block suggests, as a block nickname get used here like bear, monster, coins, one-ups, parse flag, so on and so forth. And then there are the load assets, which we already showed you, just these. And then there's a character and item images. These are basically the exact same thing. I don't know why I written three of them in the exact same script. Yes, I do have script. Okay, whatever. And then there's the classes. These, of course, I'm gonna skim over all the classes because there's like a million of them. But those are pretty simple. There's a base class that represents any. Well, base class represents any object in the game with position and velocity. It can also apply gravity. The block class represents static objects in the game world. The character represents the player character movements, jumping, and interaction logic. The coins, one-up, and heart are just special objects, obviously. The enemy, bear, and monster represents different enemies with movement and collision logic. And flag represents the end of the world marker. And then there's a level class. And there's a level class, because for the levels. And those are for initialization. Read level data from a JSON file and set up blocks to prepare background and prepares background and scenery. Basically what you see here in world.1JSON, world.2JSON, world.GStation, And then there's a game class, which is all the way. Okay. Wait a second, I'm trying to find the game class. I'm still trying to find the game class, so here it is. Okay, these define different stages of the game, like splash screen, playing, paused, even though the paused feature is slightly buggy, and game over. And it sets up the game window, clock, and initializing game status. Like for example, you define the font so that if I just have a platform here, because of the class and the font uploads, so it says a platformer. But because it's a game class, I can just go ahead and change this to whatever I want. Like for example, I was originally gonna do a simple platform as the title, but I ran out of room. But I can just do that and see now it says simple platformer. The A is out of the screen, by the way. And I don't want to extend it because I'll just extend the view. Okay. Where is it? Oh, here it is. And then there's the initialization, which is the def start here somewhere. Yep, here it is. There's the initialization, which starts below the current level and resets the hero position because you don't want the hero to be beating player to be beating every single level because they spawn on top of the flag after the first level. The event handling which processes user inputs and updates game state based on the current state of the game, and the game logic, which updates the game state, and including character and enemy actions. And there's the rendering, which are game elements, such as the def draw command, if I could ever actually find it. There it is. Which just draws the elements, applying offsets for the camera's movement, if necessary. And then since there's a main loop, just so you don't have the game running for like 1 millisecond before stopping, because otherwise that wouldn't be a game. It creates a game object, starts it, and enters the main loop where the game processes event, updates the state, and redraws the screen until the user quits. And then of course there's a world.json. These are just simple. I already explained these. Because the game state is in the assets loading part, you can just chuck in whatever coordinates, whatever type of blocks you have in here, and just have them here, because that would be easier to make levels. And if you want, you can just add another. I also made it so you can just add another one by, for example, like I could add like a, let's say, I already pre-made one here. I could like a tile. I could add another tile for the still wall. I could just add it in, and then and I could just modify it, do whatever the hell I want to this, even though this is probably gonna ruin everything. And you'll see it in the game. Also, I'm not gonna show you because I don't want to ruin this. Let's do something a bit more affordable. Maybe like this. Yeah, for this, like for example, if I were to mod PNG, I already inserted this for that for the example. If I were to go like here and just scribble a bunch of nonsense here, and then I go boot up the game, since I already entered the level data. Also, by the way, there's no, actual sounds because sound pooling is off or something. And then see, now it would flash that gibberish drawing. It's hard to see it, but it is there. It is there. And then you can here's a stone element, and you can just easily create new levels. Also, I'm probably gonna change it back because this looks hell ugly. So that's basically the entirety of the game. Now for a montage of the actual game itself, which is pretty much, almost the same, because I haven't really created that much levels. Because, the coordinates are very time consuming to try to draw and get correctly. So there it is. Enjoy the montage of, the level thingy, I guess.